I'm Allison Shipp. I'm with the U.S. Geological Survey. My background is in water resources. I'm an environmental engineer by training, so I look at water quality, water quantity, those types of issues. But probably for the last 12 years, I've been dealing with integrated science approaches, so bringing biology, geology, geography, and hydrology together to answer more complex questions. And since that time, I've been working in our regional office. And so for me, what I'm going to talk about today is sort of the 10,000 foot level of how the LCCs came to be, how the CSCs came to be, and what the departmental vision is. And these are definitely integrated activities, which is kind of why I was drawn to it, and I was a good fit for working in that arena. I'm going to talk a little bit about the IPCC, which is an international research group that looks at climate issues, the creation of the DOI climate science centers, the drivers, which, you know, for those of you who saw the happy talk, this is the downer talk when we get to the drivers section. Then we'll get back to a little bit of a happy talk when we talk about CSCs, LCCs, and working together. And after I finish my part from the DOI perspective, you're going to hear then from the Climate Science Center perspective and the LCC perspective on the ground. So in 1988, the IPCC was created, and the federal government of the United States agreed to put a group of researchers on the panel that was going to write a report about whether or not there was actual climate change happening. And some of you are way too young to know this, but there was a time we were not allowed to use the words climate change, global warming, climate impacts, anything along those lines we were not allowed to say in any kind of government report. You could not write those words. They would be deleted. We had to say things like impacting weather, or weather phenomena, or changes in temperature, you know, but no, you couldn't say climate change. When the 1990 report came out, that began to shift, and even a year or two before that report came out, when we knew it was coming, we began to feel a little bit more comfortable, and we wouldn't get the big red line if we said something along those lines. Even for a while, we used the term global change rather than climate change, or global impact rather than climate impacts. Just as a brief history, the IPCC writes reports on 3 different subcommittees. Those come out periodically, and the last big report was done in 2007. They've had a couple of small reports come out since then, but we think there's going to be a big synthesis report coming out 2014, probably October. It's an international report, scientists from all over the world coming together, making their best guess at what impacts we're going to be seeing over the next 15 to 20 years is usually the way those are written. While all of that was going on, 1988, 1990, we began to be able to use the word climate. We started talking with our partners, Fish and Wildlife, Park Service, Bureau of Reclamation, BLM, about what's going on, you know, in your landscape. What's happening that USGS can bring science to bear on? And one of the big questions that kept coming back related to what are the impacts on wildlife? We're trying to restore wetlands, or we're trying to restore prairie lands, or we're trying to do some other type of effort to improve the condition of the wildlife, but we've got this wild card out here called climate change, and we don't know what to do in order to address what's going on with climate change. Can you guys help us? And so we began to have listening sessions all around the U.S. to hear from partners about what their issues and concerns were. And because of that, USGS decided we should set up what was then called the National Wildlife Climate Change Science Center. And it was going to be a nationally based climate science center that had what we called hubs out on the landscape. And we would be helping our partners by conducting assessments of climate change impacts on wildlife. And the Department of the Interior heard about it and said, wow, that's a really great idea. We're going to make it our idea. And so in September of 2009, the Secretary of the Interior wrote a secretarial order that created the Department of Interior Climate Science Centers. And that's how they came into being. That's how they were created. They used the same model that USGS had as hubs out on the landscape, located at a university so that we could pull information from, young minds, minds that were beginning to look differently at how climate was impacting the landscape, and work also then with the land managers from Fish and Wildlife, Park Service, USGS, BLM, BOR, Corps of Engineers, any of those groups that would be interested in what was going on. At the same time, Fish and Wildlife was working, asking similar questions, and trying to figure out how to get all of the partners to the table, because the problems that we were dealing with were very complex and you couldn't fix them one issue at a time. And for those of you that were here last night, you heard some of that discussion about, whether or not it's best to look at things in a singular problem versus this is what's happening over the whole landscape and how can we address those questions. And so we looked at that, department looked at that and said, we need to bring more people to the table to work together. And they wrote the memo to include creation of LCCs. So when we talk about who does the Climate Science Center serve, the view from the department is that they will serve tribes, other federal agencies, regional organizations, states, local levels, counties, cities, any organization that is dealing with a major climate impact, we can help to serve. And at the same time, the LCCs are a huge part of that group. And they're a part of that group because they bring all of those key partners together to the table so that when the climate science centers go out and say what issue is most important, we can go to an LCC who's already pulled the partnership together and they will give us answers to those questions. All right, here comes the Debbie Downer part of the talk, the drivers. And that means why did this suddenly bubble up in 1998 or 1988, 1990 timeframe? What were the issues that were going on at that point in time that allowed our congressional body, our Department of the Interior, to say, all right, we've got to stop talking about this in circles and we need to address it head on? And since we're in Oklahoma, I'll use Oklahoma to talk about some of the issues that were driving the complexity of this problem. One, it's fragmented geography. If you look at major roads and highways, you're cutting up a lot of the wildlife area. You know that you're having impact on how water moves through a system every time you put a road in. But it's not just roads, there are also railroads, transmission lines, urban areas, minor roads, cropland, and even more so now than in the past, we're seeing increased oil and gas development along these same areas. Occasionally in the same corridor, other times they're in new landscapes that we would normally not have been able to retrieve oil and gas from, or other minerals in other landscapes. And so the impact that we're seeing, this is one piece of that puzzle that causes issues that allow us to say, okay, we've got to start talking about this more seriously now. One of the other topics that we talked about last night over the dinner was the issues and concerns with population growth. And if you just look in the Oklahoma to Dallas corridor over several decadal periods. This is the 80s, the 90s, 2000, 2010, projected in 2020. You can see that we have increased the population load. And that increase in population means we need more electricity generated, we're using more water, we've impacted habitat to a greater degree, we've impacted the croplands, we've probably changed what we're growing, we're changing what we're putting on the landscape as far as how much fertilizer, how much pesticide. So all of these things are going into it. 2030. And you can see the I-35 corridor becomes an almost solid red line between Oklahoma City and San Antonio, Texas. And the East Coast doesn't look that great either, but the water, it's coming, it's just not the kind of water that you wanted. If you look at the Panhandle, and I'll apologize, but this is what I have the slides for, is Florida, and while we all love to go there to visit, this is the impact that they will be seeing. In the bottom right hand, you see the parking lot of one of their state fish and game buildings. And with a change in sea level rise that's predicted over the next 50 years, the water has now moved up into the grassy area. You can see we started, you see no water in that picture. We see it moving into the grass, and in another 50 years, it's in the parking lot. So the question that this community has is, how do I address this? If this is what's predicted, what do we do to fix it? Do we harden the beaches? Do we raise our ground level? Do we put a giant containing wall around it the way New Orleans has done? You know, build levees so that the water can't get in? Do we move all of our buildings up? Do we plan to put no new structures in this area? Those are the types of questions that we're being asked. And the CSCs are trying to do this through a new paradigm. We're trying to link physical, biological, and social activities to be able to answer these complex questions by bringing multiple brains in. So people that are engineers and people that are biologists and people that are climate change researchers early in their career who may have a new idea about how to approach looking at these complex problems. The structure and function is that there's a USGS Science Center, and we sit at a university, in a university facility, and we work hand in hand with the host and the consortium. And in a minute, I'll show you a picture, and you'll be able to see who all the different players are in this CSC. We have a stakeholder advisory council, which is comprised of federal agencies and tribal leadership that help us to define what our science and research questions are going to be. We have a science implementation panel. They help us rewrite those questions so that we're getting the right answer out. Because those of us that are at that upper level, sometimes what we think we're asking is not the question we're actually asking. And so we've got to have the scientists that'll help rephrase that to make sure that we're asking it in the right way. There's a science agenda, a science plan, and we do a lot of government-to-government consultation. And this is what the whole CSC looks like. There are 8 of these around the U.S. They all have fuzzy boundaries, so there are definitely times that our Climate Science Center will work further north in the plains and go up into Kansas or go into Oklahoma. We may work further west into Arizona. We definitely work further east into Louisiana regularly. And then there are times that their climate science centers may encroach on our geographic landscape. The bigger term goal is that we have seamless data sets, seamless understanding of what's going to be impacting the landscapes across the U.S. related to climate. And there are multiple LCCs within each of the climate science centers. The approach is to be short-term, tactical research initially and from time to time. So if someone comes to us with a question that this is a huge issue, I've got no water, all the wells in this area have gone dry, what's going on? What can you help us with? We can get on the ground and we can try to answer those questions quickly. But our job is also to say, what question are they going to be asking me 10 years from now that I need to be researching now so that I can answer it 10 years from now? And that's a much tougher nut to crack. It's very hard to get in there and figure out what someone's going to need 10 years from now. We do all kinds of advanced applications, and we've got to monitor to make sure we understand what really is going on. This Climate Science Center touches on 6 LCCs, and it's a fairly small landscape for Climate Science Center size. However, there's huge diversity across that landscape, both east to west and north to south. If you look at the southeast, they're looking at the eastern part of Louisiana, they're looking at Mississippi, Alabama, Florida, Georgia. The climate in that region is very similar across that landscape. But if you go from middle of Louisiana to Arizona, extreme changes in climate between those two locations. So we're a little bit more compact as far as our square miles, but the changes that we see are very dramatic. The 10,000-foot look, the DOI look at the LCCs is they wanted to have partnerships on the landscape to help make sure that we're addressing issues that are important to people on the landscape. That's to land managers. They want to ensure that they do the right things in the right places based on sound science. The Climate Science Center's job is to supply the climate component of that right science. They're self-directed, they're non-regulatory, they're private, state, and federal agencies working together, and it's supposed to be a seamless network founded on science. So in the view of the department, the USGS serves as the science agency. Fish and Wildlife is a management agency, and they saw that as a really strong partnership to build, which is why a single secretarial order created both the CSCs and the LCCs with the expectations that they would work together. So here's the bigger picture of where all of the LCCs are. And the intent is this will end up becoming a seamless look across all of the U.S. The LCC functionally offers a landscape perspective for conservation activities. If you talk to a wildlife refuge manager about issues, he will tell you what's going on his refuge. My little piece of coastal wetland, this is my concern. This is where I want to work and deal with issues. If you talk to the LCC, they will talk about the whole coastline, not that one piece that the federal agency controls as a refuge, but the whole system. The biggest benefit that we have is working together, and that is with the tribes, other federal agencies, NGOs, private landowners. We've brought the universities in. We've got our LCC partners, which are bringing people to the table. And we're trying to deal with some of the most complex science and research questions of our time. As was pointed out last night in our initial opening keynote talk, the Earth is, a single organism in itself. And anything that we do in one area may have an impact in another area. The complexity of dealing with water issues, climate issues, habitat issues, contaminant issues, all at the same time, with that big unknown of really what is the climate impact going to be, and what's the timing of that, and how will things change and adapt to deal with it, is why we've brought you here. Because you're going to be helping us by bringing in new ideas, new ways of thinking, new lines of research that maybe have not been addressed before. The principle of this is to begin with what those questions are. What are the user's needs? And then figure out how to get there. So worry more about what is that process, not I have a report due the end of this week and I just need to get it done and out the door, but what is the best way to answer this question? And it gives us a lot of stability, being able to partner with a federal agency that is established and has permanent employees and young minds that can come in and rotate out and then come back into the process at different points when different needs are identified. And then we have a way that we'll look to see how successful are we being? Are we making a difference in the decisions that management is making? And are we making them in a timely fashion?